Hello, wonderful learners. So I have this question. It says in a nuclear reaction, the mass defect is 2.0 times 10 raised to minus 5 grams. Then calculate the energy released, given that the velocity of light is 3.0 times 10 raised to power 8 meters per second. And also calculate the power consumed or dissipated if the reaction took 2 minutes to complete. All right, so let's see. We are asked to calculate two things. First, we are to calculate the energy released. And we know that whenever they give us mass defect and then velocity of light, we know we are talking about Einstein equation. And Einstein equation say energy released is equals to the mass times the velocity of light squared. So let's bring out the data given. The energy released is question mark. We're going to look for it. The mass defect is 2.0 times 10 raised to power minus 5. The velocity of light is 3.0 times 10 raised to power of 8 is grams meters per second. And then they also say we should calculate the power consumed. We know that power is going to be energy divided by the time. So our time is 2 minutes. Now, these are the data given, right? So let's go into conversion first. Mass is in kilograms. So we don't use grams because the velocity of light, which is a constant, is given in meter per second, which is a standard unit. So, and kilogram goes with meters. So we have to convert it. Time, we have seconds here. We have to also convert time to seconds. So how do you convert grams to kilograms? You divide it by 1,000, right? Whenever you have 1,000 grams, is equal to 1 kilogram. So it's divided by 1,000. So if we divide this by 1,000, it's same thing as saying times 10 raised to power minus 3. So it gives us what? Kilogram. So this can be arranged as this minus 8 kilograms. Okay, so let's talk about our time. Our time is 2 minutes. We don't use minutes because of this unit. They say per second. So we're converting minutes to second, and there is going to be 2 times 60. So it's going to give you 120 what? Seconds. So that's the time we're going to be using. But first, let's use the Einstein's equation to find what? Our energy released. So E is equals to the mass is 2 times 10 raised to power minus 8 kilograms times velocity of light 3 times 10 raised to power 8, and C is squared in the equation, so we'll put square here. 2 times 10 raised to power minus 8. This square will affect this 3, so it will be 3 square times, it will also affect this 8 times 2, right? Okay, so we're going to be having 2 times 10 raised to power minus 8. 3 raised to power 2 is 9 times 10 raised to power 16. So we're going to be using indices now. We'll multiply the base and add the powers. So we have 2 times 9 times 10 minus 8 plus 16, right? So this is going to give you what? 18 times 10 raised to the power of 8. But then this has to be in standard form. So it's going to be 1.8 times 10 raised to the power of 1 times 10 raised to the power of 8. 1.8 times 10 raised to the power of 9, since its energy is in joules. But whenever you have 10 raised to the power of 9, you can call it megajoules. So this is where we're going to be using this value to find our power. So power is equals to energy divided by time. So it's going to be 1.8 times 10 raised to the power of 9 divided by time, which is 120. So let's divide 1.8 exponential 9 by 120. So we're going to be having 15000000. How many zeros are these? 6 zeros. Another 0. Power is in what? Watt. So this P is equals to 1.5 times. Okay, let's consider the 6 zeros. So it will be 15 times 10 raised to the power of 6 watts. So we have 15. 10 raised to the power of 6 is what? Megawatt. My bad. This 10 raised to the power of 9 is gigawatts, please. Gigawatts. Giga. So since we are talking about energy now, it will be gigajoules. If it was for power, it will be gigawatt. Now, let me just use this method to explain something. Anytime you have 10 raised to the power of 3 is kilo. If you have 10 raised to the power of 6 is mega. If you have 10 raised to the power of 9 is giga. If you have 10 raised to the power of 12 is tera. So please, let's have it in mind. So if it is for power, it will be kilowatt. If it is for energy, it will be kilojoules. This one megawatt or megajoules. This is gigawatt or gigajoules. And this is going to be terawatt or terajoules. Okay, this is where I'm going to stop in this calculation. I'll see you in the next video. Bye for now.